Hello student, welcome to the topic that is eigenvalue and eigenvector in case of the DSP unit number 1, that is DSP preliminaries. So let's proceed for the statement how to find out the eigenvalues and eigenvectors for a given matrix. The statement is simple one. Find EV, that is eigenvalues, and EVR, that is, let's say, the eigenvector for the matrix 4 6 10 3 10 13 minus 2 minus 6 minus 8. So this is what the order we can say for this matrix is nothing but 3 by 3. So here the matrix is nothing but the A. So we can call this particular matrix, let's say this is the matrix A. I will say this is the matrix A equal to, so this is nothing but the matrix we are having. So use the same matrix over here to solve this necessary and sufficient condition. So for this necessary and sufficient condition to satisfy, we must obey this particular statement, that is a minus lambda I, its determinant must be equal to 0, so as to get actually the eigenvectors also, that is x. But right now we are interested in eigenvalues, that means lambda. So when we say it is eigenvector, actually we need to find out the x value of x. That we will see later on. But first of all, just concentrate on a minus lambda I. So before proceeding to directly the determinant calculation, let's proceed to calculate how to get the a minus lambda I. So in order to get the a minus lambda I, so for that one, let's proceed how it will be obtained. So a is already with us, that is nothing but this matrix lambda into I. This can be calculated with the help of the, let's say, the simple calculation, that is lambda into I will be this time, obviously it will be 3 by 3 matrix, so it will be lambda into 1 0 0, then 0 1 0, this is nothing but 0 0 1. So this is how lambda into this term will give the output as a let's say it is for this case it will be nothing but lambda, this will be lambda, this will be lambda, and this lambda will be obviously taken inside. So this is nothing but our lambda into I. Now this will be sufficiently subtracted from each of this term, whatever the term we just mentioned over here. So these terms which are diagonally arranged like 4 10 minus 8, so it will be subtracted from, let's say, 4 minus lambda, 10 minus lambda, minus 8 minus lambda. So this will be just provided over here. So 4 minus lambda, next is nothing but 10 minus lambda, next is nothing but minus 8 minus lambda. So this is how it will result in. Now once we got it, our aim is to get actually the value which is nothing but a minus lambda I equal to 0. So to get all these values, we need to proceed with the further calculation over here. Now what is that further calculation? So to get the determinant of 3 by 3 matrix, let's solve it with the approach that this is where we can just grab it. This is 4 minus lambda, so that is 4 minus lambda into what? 10 minus lambda into this minus 8 minus lambda. So that is what done over here. Minus 13 into 6, that is with the minus sign. So it will be nothing but the value plus 7. That is nothing but the value plus 78. In order to solve for the second term, so this will be minus 6, which is just provided here. 3 into, let's do it. So this 3 into what? This 3 into minus 8 minus lambda and minus 2 into plus 13, that will be with the negation. So this is what this operation. Now in order to deal up with the last value, that is nothing but actually plus 10 into this will be suppressed, this will be suppressed, so it will be 3 into minus 6 minus this one, that is minus 2 into 10 minus lambda, this will be multiplied. Now this entire things will be simply solved over here. So just multiply these two values. So how it will be? it will be nothing but 10 into minus 8, that will be minus 80. 10 into minus lambda, minus 10 lambda, minus lambda into minus 8, that is plus 8 lambda, minus lambda into minus lambda, that is nothing but lambda square, and lastly it is 78. So this is how this entire term will be solved, which is nothing but the bracketed term. So afterwards we can solve, let's say, for the second case. So in case of the second one, minus 6 means this entire term has to be multiplied. So 3 into minus 8, that is minus 24. Then 3 into minus lambda, that is minus 3 lambda. Later on it is plus 26. So this is how the second bracket can be solved, and it will be multiplied by minus 6 overall. Next, it is the multiplication between the other terms, that is 10 into rest of the values over here. So what is that rest of the value? It will be the combination of this entire thing. So that is nothing but result in 2 minus 2 lambda, because this is nothing but minus 18 plus 20, that is 2 minus 2 lambda, and multiply it by 10. So this is how we can solve it. Now on further simplification, the values will be reduced like this: 4 minus lambda into lambda square minus 2 lambda minus 2, minus 6 into minus 3 lambda plus 2, plus 10 into 2 minus 2 lambda. So on solving it further, that will give the clarity to the statement. So it will be 4 lambda square, 4 into minus 2 lambda, 4 into minus 2, later on multiply by minus lambda to each term. This is how it will be done. Later on just separate out the terms, so it will be giving overall the characteristic equation, that is nothing but minus lambda cube plus 6 lambda square minus 8 lambda equal to 0. Now once we got this characteristic equation, remember here it has to be equated with the 0. If you forget it to equate with the 0, you will not be able to get the values which we intended, that is nothing but the values of eigen factors or the eigenvalue, that is lambda. So in order to get this lambda in a perfect way, let's solve this characteristic equation. So obviously it will have total 3 roots. So since it is with the degree, that is lambda cube, that is 3. So obviously it will have the 3 roots. So these 3 roots for this characteristic equation are nothing but our eigenvalues. So lambda equal to 0, this is what the first root. Second root will be obtained by solving this characteristic equation. So it can be solved like lambda square minus 4 lambda minus 2 lambda plus 8 equal to 0. So lambda into lambda minus 2, that is what the first factor which we can get, minus this is nothing but 4 lambda. Let me just check over here. Minus 2 minus 4, yes, it is the same one, minus 2. So this is how it will be simplified further. So lambda minus 2 and lambda minus 4, these will be the factors. So lambda equal to 2 and lambda equal to 4, that is what the values we will get. So this is not the part for getting actually the eigenvalues for the given matrix. Now in the next lecture we will be solving on how to get the eigenvectors for the same matrix. So thank you everyone. Thank you very much.